let's look at the one last verification that we'll need to do, at least on the node, and that's just to validate that the signature is of a proper form. We got to at least do that. Again, the only way for us to guarantee everything's good is by getting the from address and comparing it, but we still should do this as a sanity check. So I'm going to go back into our blockchain project here, and I'm just going to pull out this verify signature function. I'm going to put that in our signature package as well. There's not a lot going to go on here. We're just going to subtract that Arden ID and make sure that the V value is 0 or 1. This can make sure that we're playing within the scope of our protocol. If somebody's talking to our blockchain by accident, this would catch that pretty quickly. And then this crypto function, all it really does is it validates the form of the signature. So it takes the V byte, takes the RNS. This is why we keep things in RNS. Most of the APIs want it in the RSV format. Homestead is a version of Ethereum that's really old, so I just said false there. But you can see here, it just validates that the signature is matching the protocol rules. It can't validate that the signature is correct as it relates to the sender. We're going to have to do that with from. But it's just a basic sanity check for the signature. So I do want to put that in. And I'm going to also just push that up here. So get commit minus AM, or just added the signature validation. So we see that there's a lot of math kind of involved to make all this work, but we now have all the different parts of the code that we need. And I just want to walk through that one more time, just so we have a good mental model of what's going to happen here. So the idea here is Bill's going to have the private key, keep it private, and then basically Bill is going to be able to use the private key to generate what the address, Bill's address, is going to be on that public blockchain, right? When we get the address, essentially going from private key to public key. If I have a private key, I have the public key pair. So I have an address, right? Maybe my address again here is 0xF1D ... Okay. Now, what happens next? I want to send a transaction. So I'm going to say it's from my address, 0xF1D. I'm going to say it's to some other address. I'm going to say I want to send $10. OK, great. Then I'm going to use my private key, and we're going to sign the data. And part of the signing is stamping it and all that good stuff. Then we send the data and the signature over the wire, and it gets to the node. When the node gets this, the node is going to take that transaction. It's going to take the signature, and it's going to run it through those crypto functions. And what it's going to do then is get the from address. It's going to get some from address. Hopefully, it's 0xF1D. And then what it's going to do is compare that from address with the from that's inside the transaction. If it matches, we move on. If it doesn't match, then we're not going to accept this transaction. We've also, at that point, verified that the signature has proper form, had the Arden ID in it, those types of things. But this is going to be critical for us. If I don't do this, then we're just blindly kind of trusting everything, I think. And I like this extra sort of sanity check. This is going to protect. It's not going to hurt Bill if we don't do it, because we're not going to end up with that address. We're going to end up with someone else's address. And honestly, it's not even going to be somebody else's address. It's going to be a random address. And now you're going to lose money because you're going to park it somewhere that nobody has a private key for. So I'd rather be safe than sorry here. So that's what we've kind of set ourselves up for now with our signature package. We have the ability to take data, sign it, send it, extract the from, and validate. Pretty cool stuff. And so now, with this code in place, we have the support we need to do digital signatures. The next step now is to start thinking about what our blockchain database is. What is the information that we have to store inside the block? I like thinking of it as a database because that's what it is. And again, it's going to be like a database of what? Accounts. Accounts being these addresses. Again, decentralized. So the address isn't registered. It's based on your private key. Every time you use a different private key, it's like having a different account. There's this saying that I hear all the time, not your private key, not your money. Exactly right. All right, so that's critically important. So the next thing you do is kind of explore what our blockchain is going to be looking like. What is our, really, what is the, think of it in two ways, a database and the blockchain that's stored on disk and how they kind of stay in sync. So that's really the next thing we need to talk about.